Real numbers. So we know how to categorize them, but what are the properties of these unique set of numbers? Chances are is that you've been introduced to them before, but you probably stopped paying attention when the teacher started talking. So here's a review of the properties of real numbers. Right now, this probably doesn't make much sense, so let's look at each of these a little more in depth. But I want to go ahead and note something right now. If you look at the very bottom, the last four, they're written in a different color. I did this for a specific reason that I'm going to get to a little bit later. So let's start at the top. First, you can see we have the commutative property. This comes from the French meaning to move around. The addition just lets us switch back and forth and move around the numbers. The commutative property of multiplication does the same thing. Now, if you look below that, the associative property is a little bit different. So with the associative property, we're just changing the terms within the parentheses. Now we look at the identity property and the inverse property. For the identity property, you're taking a unique element and you want to get it back to the original number. In the case of addition, you're adding 2 and 0 and you're going to get out 2. So 0 is going to be the unique element for the additive identity. Multiplication, you can take 2 times 1 and you'll get 2. So 1 is a unique element. The inverse property, again, there is a unique element included, but the unique element is different and it's based off of what the original number you're putting in is. For the additive inverse, you want to get out 0. You're going to take the original number and then take the negative and add the two together. So you can take 2 and add negative 2 and you get 0. In the case of multiplication, the inverse. So you would take the number, multiply it by 1 over itself, and you'll get 1. So 2 times 2 to the negative first, or 1/2, which gives you 1. Look at 2. First is the distributive law. We're going to say that the number in front or in the back of the parentheses, we're going to distribute that over the numbers inside the parentheses. The other is the closure property. It's saying that for any values that we put in, as long as they're real, if we add them or multiply them together, we're going to get another real number out. So now we're down to the bottom 4. If we remember, these were in a different color. They were in a different color because we can prove these using the other properties. So we're going to start with the first one, which is 0 times a equals 0. So we want to prove that. I'm going to start with a plus 0 equals a. And we know that this is true because it's the additive identity. So in the first step, we're going to say that a plus 0 times a equals a. In the next step, we're going to say that 1 times a plus 0 times a equals a. It's the multiplicative identity. Use the reverse distributive law, and we're going to say that 1 plus 0 times a equals a. The next step, we're going to say that 1 times a equals a. It's true because of the additive identity. 1 plus 0 equals 1. Final step, we're going to say that a equals a because of the multiplicative identity. 1 times a does equal a. So we've just proven that a times 0 equals a because a plus 0 equals a by the uniqueness of 0. So now that we've proven a times 0 equals 0, we're going to go on to the next one, which is negative 1 times a equals negative a. So we're going to start with a plus negative 1 times a equals 0. That, which is 1 times a plus negative 1 times a equals 0. We can do this because it's the multiplicative identity. So then we use the reverse distributive law to get 1 plus negative 1 times a equals 0. That equals 0 because of the additive inverse. So we get 0 times a equals 0. Since we just proved that that is true, we know that 0 does equal 0. So that a plus negative a equals 0. So, because of the uniqueness of the additive inverse, we know that negative a is going to equal negative 1 times a. To the next one, which says the negative of negative a equals positive a. I want to start by comparing two different equations. The first one says that a plus negative a equals 0. This is true because it's the additive inverse. But the second one of negative a equals 0. Again, this is the additive inverse. Now I want to just focus on the similarities between these two. And the way I'm going to do that is I'm going to use the commutative property of addition and I'm going to line them up. So I can see that negative a is the second term in both of those equations. They both equal 0. The only difference is that the a and the negative of negative a are added to that negative a and they get 0. So by looking at that, I can see that the a and the negative of negative a are going to be equal. Now that we've proven all the other ones, we're just going to get on to the last one, which says that negative 1 times negative 1 equals positive 1. I'm going to start with that since that's what we want to prove. Step 1, I'm going to say that we have the negative of negative 1 is going to equal positive 1. We know that that's true because we already stated that negative 1 times any real number is going to equal the negative of that real number. I can just say that positive 1 equals positive 1. We know that's true because what was proved was the negative of a negative real number equals a positive real number.